Let us do the fourth problem of this exercise. So the fourth problem is, it is given secant A plus tan A equals P. Show that sin A equals P square minus 1 by P square plus 1. Let's take the right hand side now. The right hand side is P squared minus 1 by P squared plus 1. This is equal to, instead of P, let us substitute secant A plus tan A. So it is secant A plus tan A whole squared minus 1 by secant A plus tan A whole squared minus 1. So now expanding this, you get secant squared A plus tan squared A plus 2 secant A tan A minus 1 by secant squared A plus tan squared A plus 2 secant A tan A minus 1. Sorry, it is plus over here in the denominator, it is plus 1. So now in the numerator we see secant squared A minus 1. So what is secant squared A minus 1? That would be tan squared A. In the denominator you see tan squared A plus 1, which is nothing but secant squared A. So I can write it as, the numerator as secant squared A minus 1, I'll write it in one step as tan squared A plus tan squared A plus 2 secant A tan A by here secant squared A, tan squared A plus 1 becomes secant squared A plus 2 secant A tan A. The tan squared A plus tan squared A, I can write it as 2 tan squared A plus 2 secant A tan A by 2 secant squared A plus 2 secant A tan A. Now what is common here? Tan 2 is common and tan is common. So I can write it as 2 tan A into tan A plus secant A by, what is common here? It is 2 secant A into secant A plus tan A. Okay, so the tan A plus secant A, it's common over here. So what do I get? I get 2, I can cancel it, and I can write the tan as sin A by cos, say, by 1 by cos A. The cos A gets cancelled, and I get sin A, which is nothing but the, what we have over here, it is the left hand side, that is the sin A over here. So the left hand side is sin A. So now I have got the left hand side equals right hand side. So that's how you solve this particular problem.